Welcome to part 2 of our instructional video for making a parallel plate electrochemical reactor. We will start this video with a comprehensive overview of the parts that were fabricated in the previous video. By the end of this video, you will have an electrochemical reactor ready to begin experiments. Firstly, we have our two acrylic exterior frames with holes on the perimeter for the threaded rods. One of the frames has a hole in the middle to accommodate our anode. Next, we have two acrylic interior half cells which we cut and tapped holes to house the tubing and nylon glands. The working half cell has an extra hole to accommodate the reference electrode. At the top of the screen, we have four rubbers that were cut to the same size as our acrylic interior frames. Below, we have a stainless steel current collector cut to the dimensions of our interior half cell. Next, we have our 8 threaded rods with wing nuts already screwed into them. Here we have our carbon felt electrode which will serve as our cathode. A titanium coated with iridium oxide will serve as our stable anode. We cut a cation exchange membrane which will rest between the two half cells. On the right, we have our accessory parts: nylon glands, silicone grease, washers, and Teflon tape. Start by placing the threaded rods into the cathode exterior frame. Make sure that the washers and wing nuts come down to the same length on the threaded rods to ensure a flat, level frame to construct the remainder of the cell. Take one of the rubbers and coat it with a thin layer of silicone grease on both sides and place it in the center of the exterior frame. Lay the cathode interior frame flush with the rubber to minimize potential sources of leaks. Coat another rubber with silicone grease and lay it on top of the interior frame. Place the stainless steel current collector over the center of the rubber. We don't want the stainless steel to touch the solution because it is a good reducing agent and may corrode over time. Next, place the carbon felt cathode in the center of the cell so the edges make contact with the current collector. Try to maximize the surface that comes into contact with the collector to ensure equal charge distribution when a current is applied. Here is the top view of the cathode half cell thus far. Here is a side view of the cathode half cell thus far. As you can see, the tab that extends from the current collector is not in the same direction as the holes of the interior frame, thus minimizing clutter. Place the cation or anion exchange membrane on top of the cathode and then coat and place a rubber on top of it. Place the anodic half cell over the rubber and make sure that it lines up with the cathode half cell as best as possible. Place another rubber on top of the interior cell and fit the anode into the half cell compartment so it sits slightly above the membrane. Shimmy the anode exterior frame over the threaded rods in the anode and press it gently against the interior half cell. Place the washers and wing nuts over the threaded rods and loosely tighten all of the wing nuts. Once the cell is on its side, you can proceed to firmly tighten the cell. Avoid over-tightening the cell and bending the frames because that will cause leaks. After tightening by hand, tighten at most 1/4 turn with the pliers. Finally, we Teflon tape all of our nylon glands and screw them into the tapped holes for the tubing, anode, and reference electrode. And there you have an electrochemical cell. Here is a list of the parts used in constructing our reactor, for a total cost of about $500 per cell. Feel free to contact either William or James with any further questions. Thank you for watching.